Alright, let's get started with Unit 1, Lesson 1, where we're going to create and analyze graphs. Now the graphs that we're going to be creating are scatter plots, which means we're just plotting points. Points are also called ordered pairs, where you have an x value and a y value, and you place it on a coordinate plane like you see here. So you have a horizontal x-axis, you have a vertical y-axis. Now if your x value is positive and your y value is positive, then you're going to plot your point in quadrant 1. If your x is negative and your y is positive, then you're plotting in quadrant 2. If both are negative, then you're in quadrant 3. And if x is positive but y is negative, then you're plotting in quadrant 4. You always start at the origin, which is where the x and y axes cross. That's where you start plotting so that you end up with a point in the right place. Now if you look at your notes, you notice that the grid that you have doesn't look like it has 4 quadrants, and the reason for that is that our table of points has weight, which is all positive numbers, it has price, which is all positive numbers, so we don't need any of the negatives. So if we used the entire coordinate plane, which we could, then we would have 3 quadrants that were just sitting there empty and taking up space. So we've just pulled quadrant 1 out, the part that we need for our scatter plot in this problem. Now think about walking into a store to buy some frozen yogurt. You're going to fill your cup and then you're going to go check out. So the price that you pay, you don't know what that price is until you have filled your cup with the amount that you want. So the independent variable, the thing that happens first, is the weight. How much do you put in your cup? And then the output, or the result of that, is the dependent variable. That's your output. That's going to be the price. So when we're talking about an ordered pair, the independent variable is x, the dependent variable is y. In this table, the first column is our x, and the second column is our y. We could take the values in this table and we could write them as ordered pairs, like 2, $1 and 5, $2.50. Those are the things that go together. We could do that for the whole table. These are the points that we're going to plot for our scatter plot. Before we start plotting the points, let's go ahead and put our labels. Since x is our weight, which is the independent variable, that's going to go on the horizontal axis. So we'll put an x over here and we'll just label this weight. The price is the dependent variable, and it is in the vertical direction, which is our y-axis right there. So we'll label this price. We'll go ahead and put our units. This is in dollars. Our weight is in ounces. Now we need to number our tick marks. Sometimes you can count by ones, but a lot of times you have to make an adjustment if that doesn't fit on the grid that you have. On my x-axis, I decided to count by ones because my data will fit, but I only numbered by 2s just to keep the numbers from being so crowded. On the y-axis, each grid mark is 50 cents, but again, I only labeled 1, 2, 3, 4, so that my numbers wouldn't be crowded. Now let's plot our points, and we're going to start at the origin, which is our corner right here, because remember we just have quadrant 1. So we're going to start at the origin, and we're going to go 2 in the horizontal direction, and then we're going to go up to $1, and we're going to put a point. Now I drew lines so that you could see my thinking, but I'm going to erase those lines because the only part that you really want to graph is the point. Let's do that again with the next point. This time my x value is 5, so I'm going to go from the origin over to 5, and then I'm going to go up to $2.50. So there's 1, 2, and 50 cents all right there. Again, I'm going to take away my lines. Try not to lose my points. And I'm going to do that with the rest of these points. Pause the video and then come back and check. So all of my points appear to be lying on the same line. If yours don't look like that, then go back and count again. Make sure you plotted your points correctly. Now, your points don't always have to be in a straight line for a scatter plot. They can be all over the place. That's why it's called a scatter plot. But in this case, they are linear. Look at our next example that gives a table that shows the score of a player on the game show Jeopardy! take just a minute, pause the video, and decide what's the independent variable and what's the dependent variable. So here's a hint. If you have time in your problem, it's almost always going to be the independent variable, because we know that time goes forward regardless of anything else that's happening. So in this case, time is our independent variable and the score is our dependent variable. Now I chose the letters T for time and P for score because it's in points, but you can use any letters. You can use X and Y here if you want to. Notice in our table that time only has positive values, which makes sense. We don't go backwards in time. The score, which I'm calling P for points, does have some positive and some negative values on there. So if you look at the grid that is given to you right here, it has some quadrant 1, and then it also has some quadrant 4 for you to plot those points. So you need to come up with some labels that will fit that grid. Go ahead and pause the video and do that. I decided to count my time in by twos, so 2, 4, 6, 8, 10, and I only labeled 10, 20, and 30 for space. And then on the score, I decided to count each grid mark as 100. Notice I have positive numbers, and then I also have negative numbers on that score. Go ahead and plot your points. So this is what it will look like if you use the same scale that I used. Now if you use a different scale, it will have the same shape, but it may be squished together more or spread apart more. It's tempting sometimes to want to connect these points, but remember, we don't know what's going on between time 3 and time 8. He may have gained a lot of points and then lost to 500, or he may have lost some points and then gained to 500. So do not connect the points in a scatter plot. Remember, you should be writing any questions that you have in this left margin so that we can answer those in class. Now let's continue to the running man problem. Mr. Brust likes to run to work. The table below shows the distance Mr. Brust is from his house over the course of his run. So this time, instead of being given all the information in the table and plotting the graph, we are given a graph. This is not a scatter plot, it's a line graph. We're given the graph and we need to interpret it or analyze it. This graph doesn't have the same behavior from beginning to end. It's going up, it's staying the same, it's going down. So we want to analyze it in terms of intervals. So I've broken the intervals up according to minutes. 0 to 6 minutes, 6 to 10 minutes, 10 to 13 minutes. You need to write these intervals on your paper. When you read a graph, you read it from left to right. And 0 to 6 is an interval of time, which is on a horizontal axis. So we're going to be looking from 0 to 6 minutes, which is right along this x-axis, and then look at the graph and see what's happening. The graph is going uphill. If we go from left to right, we would say that the graph is increasing. That means that the distance that Mr. Brust is from his house is increasing over that interval. In other words, he's running away from his house. On the next interval from 6 to 10 minutes, which would be right here on the time axis, you can see that the graph is flat right here. If it's flat, then that means it's not changing. If it's not changing, we say that it is constant. On the next interval from 10 to 13, I'll just change colors here and alternate. From 10 to 13 minutes, our graph is uphill again. It's steeper than it was before, but it's still increasing because it's uphill. He's going away from his house. Now look at 13 to 15 minutes, and this time we have a downhill on our graph, which means that the graph is decreasing. In terms of our problem, this means that he's turned around and he's going back toward his house. The distance he is from his house is decreasing. From 15 to 16 minutes, we have another flat part, which means that the graph is constant. He's standing still for a minute, and then from 16 to 20, we see that from left to right, we're on another uphill part of the graph, which means that the graph is increasing. So when we say increasing, constant, and decreasing, we're talking about how far he is from his house. Now let's add this information to the table. our first column is x, the independent variable. Our second column is y. Our independent variable is time in minutes. Our dependent variable is distance, and that is in meters. So in the first few cells, we're given the time and we want to find the distance. So I'm going to where I have 3 minutes on the graph, and then I just want to go up and find the y value or the distance value that goes with it. And so that would be 400. So just fill that in the table. Now let's go to where the time is 5 minutes, and then we go up to the graph. Now this doesn't land right on the grid, so we're going to have to approximate a little bit. It's something between 700 and 600. A little bit less than 700, so we're going to say approximately 680. You might have said 675. That's fine. Some approximation close to that. At 7 minutes, if we follow that up, then we see that the distance is 800. And if we go to t equals 9, then we see that that distance is also 800. So that was where the graph was constant. Now look at the next cell. We're given the y value 1100, which is the distance. So we're going to go up here to 1100 under distance. And we want to find the time that goes with that. So in each case, we're going over to the graph to figure out what's going on. But this time, we're looking for the time. And then for 1600, again, that's a distance. And we go over and we notice, hey, there's a time that the distance is 1600, but then there's another one right there. So we're going to have 2 times where that distance, 13 minutes, and then again at this one right here at 17 minutes. So 2 times where the distance is 1600. So now let's answer this final question. We want to know what the point 18, 1800 means. This is an ordered pair. The 18 is x, and the 1800 is y. So we can use our units to help us come up with a sentence to describe this. Remember that the 18 represents time in minutes, and the 1800 represents the distance from his house in meters. So let's write a sentence using those units. So we'll say Mr. B was 1800 meters away from his house after 18 minutes. Now you might say it differently, but as long as it means the same thing, then that's fine. Be sure that you're using the units and connecting it back to the scenario when you're asked to explain what that point means. Flip your paper over. Now we have story time. Professor Splash set the world record with a 36-foot belly flop into a 1-foot pool of water. And I would like you to sketch a graph of his height over time, but I have a video to help you visualize this.
He's known as Professor Splash, and it's easy to see why. And this from diving into just 30 centimeters of water. It's part of a new Guinness World Records ebook dedicated to sport, weird sport. To the editor in chief of the book, led by Professor Splash, are superheroes. Darren Taylor dived from a height of 11.2 meters into a paddling pool of just 30 centimeters, an inspiration to Olympians everywhere.
So take a moment to think about what a graph would look like if you graphed his height with respect to time. Remember, we said time is an independent variable almost always, so we'll put that on the horizontal axis and we'll put the height on the vertical axis. So I've labeled that height in feet. I'm going to use feet for units since that's what's in our problem. And then the platform is at 36 feet, so I put that label on there, and then I'm not sure how long it took, but I knew it only took a few seconds. So you might have started at 36 feet and said, well, his height is falling down to 0 feet, and so maybe it would look like that, but actually, as you're falling, you would be falling faster at the end. So he jumps up a little bit, and then he falls, and he's falling faster as he gets closer to the end. be sure to write a summary. Make sure you practice and ask questions in class. Bye-bye, till next time.